Hello everyone. In this video we're going to be simplifying a radical expression. We have the square root of 4 plus 2 root 2 minus the square root of 2 minus root 2, and we're going to try to write this expression in the simplest form. I'll be presenting at least two methods. Maybe I can also do a third one. So let's start with the first method. So for my first method, I'm going to do kind of the obvious thing to do. Whenever you have a radical expression and you're trying to simplify it, set it equal to something. How about x? And then square both sides. So what happens is you're going to find, by doing this, you're going to be finding x squared, but then at the end, do not forget to square root the answer. Okay? How do you square a minus b? Square the first one, plus square the second term, minus 2 times ab. This would be our a, and this would be our b, right? So now we have 2 times the square root of 4 plus 2 root 2 times the square root of 2 minus root 2. Obviously, we can kind of put these under the same radical and multiply together. But let's go ahead and simplify this first. 4 plus 2 is equal to 6. 2 root 2 minus 1 root 2 is going to be 1 root 2. Minus 2 times. Now, you can go ahead and distribute it, or notice that you can factor out a 2 here and write this as 2 times the quantity 2 plus root 2. And when you multiply it by its conjugate, yes, that's going to be a good shortcut. You're going to get from difference of 2 squares 4 minus 2, which is equal to 2. So, in fact, this expression is going to be 2 times 2 under the radical. But that's just the square root of 4, and as far as I know, it's equal to 2. So this is a 2, and multiply by 2, that's going to make a 4. Great. 6 plus root 2 minus 4, 6 minus 4 is equal to 2 plus root 2, and that is x squared. But we're trying to evaluate x, so square root both sides. Consider the fact that this is probably a positive expression. Now, how do I know that this is positive? Let's go back to the original expression and take a look. This expression is obviously less than the square root of 2, right? I mean, because you're subtracting something from 2 and you're square rooting it afterwards. And this one is definitely greater than 2 root 2, which means it's greater than root 2, right? So the first expression, I mean, you can just focus on 4 as well. It's just greater than 2. So definitely the first expression is smaller, bigger, so the difference is positive. What would happen if we switch them around? The answer is supposed to be negative, which means you would have to put a minus sign in front of this guy, right? That would kind of look, it would be a little trickier. You have to be careful. But this is the answer, right? And that's just the end of the first method. Let's go ahead and take a look at the second method and see if we can come up with a third one. So with the second method, we're going to do something like this. So first of all, keep this in perspective. We're trying to simplify something like this. If these two expressions were conjugates, then this problem would be fairly easy to do, right? Again, we would do the same thing. Set this equal to something and then square both sides and then square root the answer. Consider the fact that whether it's positive or negative. But when they're not conjugates, it's a little different, right? But here we can still take advantage of the conjugates because this one has a conjugate and this one is a conjugate. You can choose either one, but I'm going to go with the second one because that looks a little simpler. What's the conjugate of 2 minus root 2? It's 2 plus root 2. So they're going to pair up nicely. So why not take this and find out what it is? So let's go ahead and see what we can do with that. By setting this equal to maybe t, in this case, let's use a different variable. We can go ahead and square both sides. Now my idea is to find something that will help me here. When I square both sides, 2 plus root 2 plus 2 minus root 2. So for these kinds of expressions, I'm almost always using this identity, but I'm writing it in a different way. So I want to put that term in the middle. Usually that's in the middle at the end. Plus 2 times 2 root 2 plus root 2 times 2 minus root 2. Since those are conjugates, they're going to simplify nicely. This is going to be 4 minus 2, which is 2. Then you're going to get 2 root 2 from there. But the root 2 cancels out. So you get t squared equals 2 plus 2, which is 4, plus 2 root 2. That's interesting. This looks like a positive expression. Well, let's go back. Again, this expression is the sum of two positive quantities. Yes, it's supposed to be positive. I'm talking about this one. Okay, so let's go ahead and square root both sides. and then we'll get the answer. Wow. What do you mean we get the answer? Well, we just got this. So this means the original expression that I called t is equal to the square root of 4 plus 2 root 2. But wait a minute, I'm trying to evaluate what? I'm trying to evaluate the square root of 4 plus 2 root 2 minus the square root of 2 minus root 2. But isn't this equal to a sum? Yes, if I replace that with this sum, right? Because that's what I just proved. And then subtract. These two terms are going to cancel out. This is what I'm trying to find out. These two cancel out, leaving us with the answer. Wow. So basically, this is where the problem idea comes from, right? You take something like this, and then square it, get the answer, and then put one of these on the other side. So kind of disguise a little bit, right? Trying to be sneaky there so that it's not too obvious, and then present it as a problem. Okay, hopefully this kind of helped. And let's kind of think about a third approach for this one. I'm not exactly sure how to proceed, but I'm thinking about something like this. Can I simplify this expression? Is that possible? I think so. We could probably do the following. There is a formula, because this is called denesting a radical, right? And there's a formula, especially for square roots, it's not that hard. I don't think there's a formula for cube roots, right? That will be super complicated. But with the square roots, we can do one. So how does that work? It's basically, the idea is you pair this up with its conjugate and call this x, and then you square both sides and find x, and let's not call that x because we already used x and t. Let's call this y, and then we're going to go ahead and square both sides, and then from here we're going to get y squared equals 4 plus 2 root 2 plus 4 minus 2 root 2 plus 2 times the quantity 16 minus 8, right? That's an 8 by using difference of two squares. But that's 2 root 2 multiplied by that 2 is going to give you 4 root 2. So cancel these out. Y squared is going to be 8 plus 4 root 2, which means y is going to be the square root of 8 plus 4 root 2. Great. So we got the sum of these two things. How about the difference? I can go ahead and set the difference equal to another variable. How about z? And then square both sides. Again, the same type of idea. 4 plus 2 root 2 plus 4 minus 2 root 2 minus 2 times, I think that was a 2 root 2, right? We already used it before. And then these two cancel out again, and this time z becomes the square root of 8 minus 4 root 2. So this is why this is z, and if I go ahead and add y and z and divide by 2, I'll get the answer. So notice that this 4 plus 2 root 2, and that was, the first one was my y value, which is square root of 8 plus 4 root 2, right? Sorry for my messy writing. And the second one was the difference, and that was equal to the square root of 8 minus root 2. By the way, that kind of makes sense because these are supposed to be what? Conjugates, right? I should have known that. Anyways, so now we can go ahead and, since we're looking for this, we can go ahead and add these up. These two are going to cancel out, and I get this twice, right? So I kind of have to divide by 2 at the end. So the expression just turns into something like this, right? We can go ahead and divide by 2, and that should give me the answer. And then I can go ahead and add the other one. I don't know if this is going to give us the answer, but at least I tried. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.